Well, first off, it appears that we do have at least weak El Nino conditions that are trying to develop. And for that reason, back on March the 6th, the Climate Prediction Center issued an El Nino watch for the tropical Pacific, meaning that conditions are favorable for the development of El Nino conditions within the next 6 months. But as I stated, this is a very low confidence INSO forecast, which means that, which is attributed because of a lot of data that collects sea surface temperatures in those regions, El Nino regions, or the data is collected by a series of moored buoys along just north and south of the equator, and about over half of those buoys are not even recording data. Much of the sea surface temperature data are taken from a project called the Tropical Atmosphere Ocean Project, or the TAO Buoy Array, and it consists basically of 55 moored buoys that have been in place since the mid-1980s that, again, take sea surface temperature data, and they also collect data within about the lowest 1,600 meters or so below the surface of the sea. However, because, as we all know, because of budget cuts and other reasons, only a third of those buoys are about reporting on a daily basis, with the remainder of these buoys either sending no or only partial data. We certainly need more data in order to have a better climate forecast for this region. It goes along the same lines as how the National Weather Service offices launch their weather balloons twice a day. We have a series of stations all across the United States here that release weather balloons twice a day. And if we do not have as much data going in from those weather balloons, see all the weather data that we release each day from these weather balloons are being ingested into our numerous computer weather models that we use to forecast the weather with. Works the same way out in the Pacific. The lack of instrumentation that we have out there in the equatorial Pacific, with over half the sites being down now, we're not getting as much data, and so the confidence with predicting a very skilled forecast going out 6, 9 months, or even longer is fairly low. Again, this is the network of buoys that are in place across the equatorial Pacific from the TAO project. Again, all the yellow dots that you see here are actually the buoys that are actually working. All the red dots that you see here are the buoys that are not working. They're sending little or no data at all. So, other than just this array of buoy data, climate forecasters only have access to other buoys, but they drift with the climate current, so they're not always sampling or getting samples from the same area. They're moving with the shifting currents. They have availability of satellite imagery, but again, that technology is still somewhat limited. You're not actually testing samples as you would with a normal buoy. Of course, you have passing ships going east, west, north, and south of this area here that are collecting data on occasion as well. So just not a whole lot of climate observations available in that area of the Pacific. But should El Nino develop for later this summer or the fall, typically El Nino will peak during the wintertime months. During the December to February time frame, El Nino events would persist on about 9 to 12 months. Occasionally, they could last upwards to 12 years. And impacts, especially for the Atlantic hurricane season, could result in a decrease in hurricane activity late in the season. I'm talking about from maybe September, October, just after the peak hurricane season. But again, because it's a low confidence forecast, some of our long-term climate models are suggesting weak El Nino conditions. It's certainly possible that the developing in El Nino may not have an effect on the Atlantic hurricane season at all. So it's something to kind of keep and bear in mind here. A couple of other features I want to briefly talk about here and how they've influenced our weather for the fall and wintertime months. First off, we'll talk about the Arctic Oscillation. And this is just kind of a review. It just refers to the atmospheric circulation pattern in the northern and high latitudes of the Arctic. And typically, this one particular type of oscillation can overcome any kind of El Nino or La Nina impacts. So it's just kind of a temporary altering of the path of the jet stream. But typically during El Nino or Arctic oscillation, negative phase of the Arctic oscillation, we have higher pressures develop here over the polar regions and lower pressures develop along the mid-latitude, say near 45 degrees north. And with that low pressure, again, in the northern hemisphere, low pressure counterclockwise circulation around that low pressure system in the mid-latitudes allows quite a bit of frigid air to plunge south into the eastern half of the country, east of the Rockies. But during positive phase of Arctic oscillation, we have lower pressures develop here over the polar regions, higher pressures develop further south in the mid-latitudes, and so that keeps the jet stream and a lot of the cold air bottled up across much of Canada and the Arctic region. Whereas the North Atlantic oscillation, it works much the same way, except we're looking at pressure patterns further east. With negative North Atlantic oscillations, we've got weak low pressure system near Iceland, and also a weak high pressure system there near the Azores, central and eastern Atlantic here. And so these pressure systems have very little influence on the jet stream patterns, and so it allows the colder air to plunge south during negative NAOs, much like negative AOs or Arctic oscillations. So there's certainly a little bit of a correlation there. Obviously, if you get a negative NAO and a negative AO, we're looking at some pretty significant cold air diving down east of the Rockies. Whereas with positive NAOs, we have a strong Icelandic low, a strong Azores high, and so that tends to keep the jet stream again bottled up across Canada, with all the cold air staying north across the Arctic region and into much of Canada there. So it keeps much of the continental United States fairly warm during positive NAOs. Looking back really since the beginning of the wintertime months, you can see that we did have a positive AO, and actually kind of a strong positive AO, during much of December. The NAO during the month of December was near neutral, if not maybe slightly above normal, but temperatures across our region trended generally near normal during the month of December, and that's due in fact to the amount of precipitation that fell during the first 3 weeks of the month of December. It was really after about the after the heavy rainfall on the 21st and 22nd of December that we started seeing deficits in rainfall and precipitation ever since. What you see circled here for the month of January through the first part of February, for the most part, AO was negative during this time. And so that resulted in continued cold frontal passages through our area, just reinforcing shot after shot after shot of cold fronts through our region during the month of January. And so it really gave little time for the Gulf of Mexico to recover, and really gave us a very, very dry month area-wide through the month of January. As you can see here, the NAO was fairly neutral during that time, so very little impact that the NAO had on our region. The AO and NAO ever since throughout much of February and even through the first half of March have trended slightly positive. And so really temperatures have begun to moderate aside from say a couple of dips here during the mid and late February timeframe in the AO. The squiggly lines as you see here is just a kind of an ensemble climate forecast of predicted AO and NAO conditions here over the next couple of weeks. Unfortunately, AO and NAO can only be predicted out about a good 7 to 10 days out with some sort of accuracy. Anything beyond that is much of the longer-term forecast is much more difficult here. So that's why we're seeing quite a bit more variation between the squiggly lines here going out towards late March and the first part of April. Now, looking at the Arctic oscillation effect for the month of January across the continental United States, as you can see here, Most of the areas east of the Rockies saw below normal temperatures, much below normal temperatures here across the parts of the Midwest and the Ohio Valley, with temperatures 6 to 9 degrees below normal. As you can see here, much of our region saw temperatures a good 3 to 4, even almost 5 degrees below normal area-wide as a result of the Arctic Oscillation. So, but again, temperatures have kind of mellowed out ever since here. Now, I went back and looked, and assuming if we did have neutral conditions continuing now through the end of May, I went back and looked at the years in which we had conditions through those 3 months prior to leading up to an El Nino episode. And I only found 9 events in recorded history going back to 1950 in which we had neutral conditions through the March through May time frame leading up to an El Nino episode later on in the year. And if we use climatology here based on these 9 events, it's suggesting that the temperature outlook really over the next few months, it's suggesting near normal temperatures area-wide. Looking out on the precipitation side of things, climatology is suggesting near to slightly above normal precipitation through May. And but again, this is only based on 9 years or 9 episodes in which this has occurred. So I would certainly have higher confidence in climatology if I had more data to work with here, though. But that's just kind of a what-if scenario here. So certainly above normal rainfall during this time frame would certainly help with the drying conditions that we have in place right now. Now looking, comparing that to what's been official here from the Climate Prediction Center, this is looking out the temperatures on the left and the 3-month precipitation probabilities on the right. And this is again through the April, May, and June time frame. Looking at Climate Prediction Center is suggesting fairly good confidence, above normal probabilities for seeing above normal temperatures really over the southern half of the United States. I do want to point out that I think some of this is also, especially here in California and Texas and New Mexico, is attributed to the already drought conditions already in place. So again, they have soil moisture deficits are a lot less, and so it won't take as much to really heat up those drought-stricken areas. Looking at the precipitation probability, this graphic is suggesting that there is really no skill whatsoever in forecasting precipitation really over much of except for the western quarter of the United States here. So equal chances of seeing a below normal, near normal, or above normal rainfall through the April, May, June time frame. I do want to point out that the CPC forecast, seasonal forecast for last fall and winter for our region did not really do very well at all. Climatology worked fairly well for our area given the unsafe conditions in place. I'm kind of taking these really for now just kind of with a grain of salt. Looking ahead towards the summer outlook, again, CPC is suggesting above normal probabilities for seeing above normal temperatures for the summertime months for really much of the country with the exception of the northern plains and Midwest region. I do want to point out that they seem to think some of the long-term climate models are suggesting perhaps above normal probabilities for seeing below normal precipitation here for southeast Texas, much of Louisiana, southern Mississippi, and Alabama during the summer time frame. So, but again, keep in mind that if we do have El Nino conditions develop, the El Nino influences will not be felt across our region until sometime after from late summer and especially during the fall and wintertime months. So really, there won't be any kind of effects for El Nino through the summertime months of this year. Looking at the long-term drought outlook issued by the National Drought Mitigation Center, this really hasn't changed since last month's drought outlook. It's still suggesting removal of drought conditions here across the central and eastern parts of Texas, where drought is already ongoing, moderate to